is independent and different. And I want to make that abundantly clear. We know the odds, but the odds are not always the same. If they were, then we could easily predict that the Blue Bombers are going to win the Grey Cup next weekend. And they will.
How are you so sure?
Because right now, in an alternative universe, it's Monday next week, and I'm watching this YouTube video. Check your physics. Might be true. All right, let's move on to the next one. So, experimental and actual probability. Let's take a look at another way to do probability. See that little spinner right there? It's got green and red and blue. And what we're going to do is we are going to construct a table to establish its probability. So I'm going to pause. Before we continue, I need to make a quick correction. We had experimental and actual. No. The theoretical and experimental. Theoretical this is the theoretical. We have a 1 in 9 of our spins. The experimental is what we actually experiment. I had experimental and actual. I mean, theoretical is the theory of probability. Experimental is what actually happens. And so in the last one, our theoretical probability was 1 in 12, and our actual probability was 11 over 108. So our theoretical probability on these spins is that it would happen, according to the tree diagram, 1 out of 9 times. But now we're doing a second way to do it, because as you know, I'm going to test you in multiple ways to look at probability. So we're looking at RGB. This is in reference to the spinner on page 408. Who's got an RGB spinner? All right, great. Hold on to it. So I could get this. I could get red and red. I could get red and green, or red and blue. I could get green and red. I could get green and green. I could get green and blue. I could get blue and red, and blue and then green, or blue and then blue. So theoretically, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 outcomes. Does that work?
Yeah.
Okay, now let's do an experiment, or let's do another theoretical. What are the odds? 1 out of each spin, 1 out of 3. And then the second spin, what are the odds? 1 out of
6. No. Yeah.
Well, there's only 3 outcomes.
9.
No, and then my second spin, what are the odds I get a red?
1 out of 3.
1 out of 3. So I got 1 out of 3, 1 out of 3. That's 1 out of 9. So take a look at our 3 models. 3 outcomes, then times 3, 3, 3. 3 outcomes times 3, that's 9. 1/3 times 1/3, or 1 out of 3 times 1 out of 3 equals 1 out of 9. So our theoretical probability is 1 out of 9. Let's see our actual. Are we ready with our spinners? Who's got a spinner? Who's got a 3x3? Here we go, here we go. All right, so let's see what we get. Here's what I want. I want to get a blue. Okay, I'm looking for a blue, so don't spin yet. Okay, Bert. Tell you what, how about everyone spin once, and then I'll ask you your things, okay? Ready? We're gonna do 9 kids. You got one? You got one? You got one? That's 3, 4, 5, 6.
Wait, what did we get?
Who else has? 7. I need 2 more. I need 9 spinners. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we're gonna do everyone but Mr. Bobcat and Mr. Denny here. You ready? Spin. Okay, now hold on. Did you get blue?
I got blue.
What'd you get the second time?
Oh, I got blue.
Yeah. Okay, did you get blue? Did you get blue?
Yeah.
You got blue? We got 1. Okay. Did you get blue?
No.
Did you get blue?
Yeah.
Blue?
I got red.
Blue?
Blue green.
Blue green.
Green red.
Green red. Okay.
Red.
Blue. Oh, I got green blue.
Green blue.
Green.
Green. So we got 3 blues?
Oh, did you
So
get
wait,
green?
out of 9 spins,
Just 3.
I know, but I just wanted 9. Hold on. Out of 9 spins, 3 times we got blue. So what was our actual or experimental probability? 1/3. Was our actual probability the same as our theoretical probability? No. Does that mean I should get that every time?
No.
No. Doesn't mean we're lucky, so we should just keep going. Doesn't mean you should keep putting quarters in the slot machine. Or keep playing the lottery. If I win the lottery this week, am I more likely to win the lottery next week?
No.
No. It's pure random each time. All right, so we've got 3 different models now. We have our tree model. We've got our chart model. We've got our symbolic model. 3 ways to find theoretical probability. We know how to find experimental probability. You actually do it. Here's the same thing that we just did. There's your tree model. Once again, don't think we need to review it. And then there is your symbolic, just like we've done over here. So I'm going to turn off the camera. I'm going to give you one more little check, and then we'll carry on. All right. So to check with you, I challenge you to do number 6 in the assignment. And the number 6A, it said, find the probability of each event. The pointer lands on we had, what is it? I think it was 6A3. The pointer lands on a striped sector, then a solid blue sector. And we can see that there were 10 possibilities in the spinner. 3 of those possibilities were stripes. 1 of those possibilities was solid blue. So first, let's look at the insane models. When you have really large probabilities, it's difficult to draw them. Here's your tree model. You've got 10 outcomes. You've got yellow stripes, red dots, solid red, solid red, solid red, blue stripes, solid blue, yellow dots, red stripes, and blue dots. And so we had to figure out which was going to land. And there was 10 possible outcomes. Each of those had 10 possible outcomes because your odds are 1 in 10, 1 in 10 each time. However, 3 of those were possible with stripes. So we had 3 possibilities with stripes, like so. Of those 3 possibilities, they even had 10 more, 10 more, 10 more. And there were 100 possible branches. For only one of those 10 would be possible here. One of those 10 would be possible here, and 1 would be possible here. So out of 10 times 10, or 100 possible outcomes, only 1, 2, 3 of those could be actual. So our theoretical probability, according to this, was that 3 out of 100 times you would get a stripe and then a solid blue. With the chart here, we had 100 outcomes, right? Because we had a 1 in 10 spin and then a 1 in 10 spins. We had 10 spins and 10 spins. Now, I didn't put all the outcomes because, my goodness, there's only so many hours in the day. But what I did is I had, if I got a yellow stripe and a solid blue, a blue stripe and a solid blue, or a red stripe and a solid blue. And what we found out was that out of the 100 possibilities, only 1, 2, 3 of them were a stripe and a solid blue. But because we're not insane, let's just do it the easy way. The odds of getting a stripe, there were 3 stripes out of 10, 3 tenths. 30% of the time you're going to get stripes on the first spin, right? Times a 1 out of 10, the solid blue. 3 times 1 is 3, 10 times 10 is 100. Which way would you prefer to do?
The chart.
The chart? Wow, I find this way easier. Now, you do need to be able to do this and this because I need to know you understand probability. Anyone can do an algorithm and do this. I can punch that into a calculator and do it. But a calculator doesn't understand probability, it just understands algorithms. We don't just do algorithms, we do math. Would I do this when I'm dealing with 100 outcomes? No, I would do this. But if I was dealing with tossing a coin twice, heads versus tails, you should easily be able to say, what are the odds of getting tails and then heads? Well, 1 out of 4 outcomes. And if you can do that, you're looking good to start your assignment. Don't be afraid to ask questions.